Hello everyone. In this lesson, we are going to discuss how to solve optimization problems. In optimization problems, we are actually looking for the largest value or the smallest value that a function can make. These applications include application of maximum or the minimum values. Okay, so in optimization problems, we are actually finding the best value. And the best value sometimes occurs or happens at the maximum or at the minimum. Moreover, since we are going to apply the maximum or the minimum value, we are going to apply the extreme value theorem na na-discuss natin sa ating previous lesson. Okay? And here, to help us solve problems on optimization, we are going to follow some steps. So these are the steps that we are going to follow. First, if possible, sketch an appropriate diagram for the problem. By sketching the appropriate diagram, mas malalaman natin kung ano yung hinahanap sa problem or ano yung approach na gagawin natin para ma-solve yung problem. Then after that, we are going to use variables to label unknown quantities. So here, papangalanan natin yung mga unknown quantities by a variable. Whatever variable na gagamitin natin, okay lang yon. Then, we are going to use numerical labels naman for quantities that remain fixed or constant. Then after that, we are going to obtain an appropriate function of one variable only. This function is what we call the objective function. The objective function is the function that we are going to maximize or minimize. Okay? Then, we are going to determine a closed interval for the domain of f such that f is meaningful. Make sure f is continuous in its domain. So, kailangan natin malaman yung closed interval so that we can apply the extreme value theorem. Because the extreme value theorem states that if you have a continuous function um, on a closed and bounded interval AB, there is always that extreme value na mag-i-exist. And that extreme value, either the maximum or the minimum, occurs at the endpoint or at the critical point. So, dapat alam natin yung closed interval para malaman natin yung endpoints ng ating function. Okay? Next, we are going to find f prime or the derivative of f so that after that we can get the critical points of f because the critical points of f occurs when the derivative of the function at that point is equal to 0 or the derivative does not exist. Okay? Then, we are going to compare the values of f at the endpoints and at the critical point. So here, we are now applying the extreme value theorem. Then, lastly, we will accept the largest value of f in step 7 as the true maximum and the smallest value of f as the true minimum. So, whatever yung hinahanap sa problem, yun yung kukunin natin. So, kung maximum ang hinahanap, the largest value yung ibibigay natin. If minimum naman yung hinahanap, yung smallest value naman yung ibibigay natin. Make sure in giving the final answer, you must include the unit of measurement if there is a unit of measurement involved. Okay? So, para mas maintindihan ito lahat, let's consider the following examples. For problem number 1, we are going to find the number in the closed interval -3 and 3 so that the difference of the number from its square is maximized. Okay? So, following the steps that we have discussed kanina, the first step is to sketch an appropriate diagram. Now, in this case, since hindi tayo makakasketch ng kahit anong diagram, since yung involved dito ay mga numbers lang, so we will skip step 1. So let's proceed to step 2. Step 2 is we are going to use variables to label the quantities that are unknown, right? So in this case, we will now determine kung ano yung mga unknown. So you read again the problem. So by reading the problem, we can see that yung mga unknown ay yung number at yung difference, right? So sila yun ngayon yung papangalanan natin. So in our solution, okay, we will let x be the desired number and we let d of x be the difference of the number from its square. Okay, so that is our first step. The next, we will obtain now the appropriate function of one variable only. Again, as what I've said kanina, yung function ay yung objective function. And the objective function is the function that you are going to maximize or minimize. Now, in this case, since ang sabi sa problem, we need to maximize the difference. So therefore, yung objective function natin ngayon ay yung difference. Okay, so kailangan nating i-formulate ngayon si d of x. Thus, d of x is equal to, so ano ngayon yung d of x natin? It is the difference of the number from its square. Since the number is x, so we will have x squared minus x. So this is now our objective function. Then after that, we will determine the close interval for the domain of f such that f is meaningful. So in this case, since yung close interval is already given, and that is -3 and 3, therefore, hindi na natin siya kailangang hanapin kasi binigay na siya. So isusulat lang natin siya dito where x is within -3 and 3. Close interval -3 and 3. Okay? We must make sure that the function is continuous in its domain. And since here we have a polynomial function, so we are already sure that it is continuous. So wala na tayong problema doon. Then after that, we will proceed to the next step, and that is to find f prime. Okay? So it follows that, so kunin natin yung derivative. So d prime of x will be, the derivative of x squared is 2x. And we have minus, derivative of x is 1. So we have now here 2x minus 1. So we are done with step 5. Next, step 6 tayo. We need to get the critical values of f. And in finding the critical values, we are going to equate the derivative to 0. Okay? Equating the derivative to 0. So next is we have equating d prime of x to 0. We have 2x minus 1 equal to 0, right? And it will follow, if we're going to solve for x, we will have here 2x equal to 1 if you're going to add 1 both sides, right? Then solving for x, we will divide both sides by 2. We will get x equal to 1/2. So from that, since 1/2 is within the close interval -3 and 3, therefore we say, hence, x equal to 1/2 is a critical point. Okay, so we now have the critical point. Next, step 7, we will compare now the values of f at the critical point and at the end point. So we will evaluate now the function, which is d of x equal to x squared minus x at the endpoints, which is negative 3 and 3, and at the critical point, which is 1 half. Okay, so comparing the values, we will now have, through table of values na lang siguro, we have x and d of x. So you will have now the endpoint negative 3, the critical point 1 half, and the other endpoint, which is 3. So we will now substitute the values. Try to substitute negative 3 to the function. You will have negative 3 squared is 9 minus negative 3. So that will become 9 plus 3, and that is 12, right? Now you try 1 half. 1 half squared is 1/4 minus 1 half. That will become negative 1 half, right? Oh, no. 1/4 minus 1 half. That will become negative 1/4. I'm sorry. So this is negative 1/4. Okay. Then if we have 3, 3 squared is 9 minus 3, you have 6. So comparing the values, you can see here that the maximum value is 12. And since we are going to maximize the difference, therefore we need to accept the largest value, and that is 12. Pero ang hinahanap sa problem ay yung number. So what is now the value of x that gives the maximum value, which is 12? That is negative 3. Therefore, our final answer is, therefore the number is negative 3. And that ends our solution. Okay? So that is for sample problem number 1. Now let's proceed to the next problem. For the next problem, we have a rectangular box is to be made from a piece of cardboard 24 centimeter long and 9 centimeter wide by cutting out identical squares from the four corners and turning up the sides. Find the volume of the largest rectangular box that can be formed. So first step, we will sketch an appropriate diagram for the problem. So according to the problem, we have first a cardboard that is 24 centimeter long and 9 centimeter wide. So siya yung una nating i-draw, yung cardboard natin. So suppose this is our cardboard. Ayan. So the cardboard is 24 centimeter long. So this is 24 cm. And we have 9 centimeter wide. Then according to the problem, we are going to cut out four identical squares from the four corners. Okay, so therefore, suppose we will have these corners. So ito, suppose yung ating mga squares. Ayan, 1, 2, 3, and we have 4. So there. So we are done with our um, illustration. So next step is we will now use variables to label the unknown quantity. So ano yung mga unknown dito? From our diagram, you can see here na hindi natin alam kung ano yung length ng sides ng ating squares, right? And take note, our box depends on the squares that we are going to cut out, right? So therefore, the first unknown quantity is the length of the sides of the square, right? And next, we have the volume. Okay, so therefore we will let x be the length of the sides of the identical squares. Okay? And suppose v of x is the volume of the rectangular box. Okay. Now take note, the volume of a box is given by, so volume is equal to the length times width times height. So we need to know the length, the width, and the height of our volume. Since yung volume ang kailangan nating i-maximize, we need the largest volume. Okay, so therefore, yung objective function natin ay si v of x. And we can only formulate v of x if we know the length, the width, and the height of our box. Now, from this illustration here, we can actually picture out now our box. So, from here, we will now have this box. So, suppose this is our box here. So, nakat out na natin at we already turned up the sides. So, ito yung mangyayari. Ayan. So, this is our box. Ayan. Right? So, meron yung dash, dash, dash dyan. Ayan. Okay. Now, if we let the length of the sides of the identical squares be x, so therefore, this one here is x. So, x ito, x rin to, x yan lahat since we have a square, right? So, x yan lahat. Okay, x. Ito at x rin to. Yan. Now, if we are going to turn up the sides of this cutout cardboard, ang mangyayari, itong nandito, this will now be the height of our box. And since the length of that height is x, therefore, this one here is also x. So our height is x. Now for the width, this will be our width, right? Take note the whole cardboard is 9 centimeter long. Okay? And since we will cut this out, so mawawala yung x and this another x. So si 9 centimeter, we will deduct or subtract 2x's. So therefore, yung width natin ngayon, magiging 9 minus 2x na siya. So itong nandito, magiging 9 minus 2x ito. And also, our length here, this is 24 centimeter, right? 24 centimeters yan. And if we are going to cut out this two or four squares, mawawala yung dalawang x's dyan. So therefore, we have subtracted 2x's again from the 24. So that will become 24 minus 2x. So our length will become 24 minus 2x. So we now have our length, width, and height. Thus, next step now, we can give the um, objective function. Hence, we have v of x equal to the length. The length is 24 minus 2x. Okay, there. Then we have the width is 9 minus 2x. And the height, which is x. Okay? So para mas madali natin siyang ma-differentiate mamaya, let's expand the expression. So this is now equal to 4x cubed So this is negative 18, negative 48. So you have 66, negative 66x squared. And 24 times 9 is 36, 3, 216. So that will be, yeah, positive 216x. So there. Then after that, since we already have our objective function, we now proceed to our next step. And the next step is to determine the critical values. No, the um, close interval. Okay? Now, the close interval, as you can see here, our box is restricted by the dimensions of our cardboard, right? And para makabuo tayo ng box, we need to cut out four identical squares. And since the width is lesser than our length here, so nare-restrict tayo sa value ng ating width. Para makabuo tayo ng um, four squares or para maka-cut out tayo ng four squares, dapat alam natin kung gaano lang ka taas yung ating x. And since we have 9 centimeters in our width, therefore, para yung maximum value ng x, para makabuo tayo ng apat na squares, will be half of this width. And that is 4.5. Kasi more than 4.5, hindi na tayo makakabuo ng 4 squares. So therefore, our x here is limited only to 4.5, right? And yung pinakamaliit na value niya will be 0. Wala tayong ika-cut out. So, remain as the cardboard siya. So, the limit will be from 0 to 4.5 because our x should be greater than or equal to 0. Okay? So, we now have our closed interval. Then after that, we need to differentiate now our function. Okay, it follows that v prime of x is equal to differentiate for x cubed, that is 12x squared. Negative 66x squared is negative 132x. 216x is 216. Okay? So we are done differentiating. We will now get the critical points. And that is when the derivative is 0. So we will equate now v prime of x to 0. Equating v prime of x to 0, we obtain 12x squared minus 132x plus 216 equal to 0. Okay? Then we will now solve for x. Solving for x para mas madali, since this is a quadratic equation, we will first factor out 12. So that will become, so this is x squared minus 132 divided by 12 is just 11, right? So this is 11x. And 216 divided by 12 is equal to what? This is 18, right? So this is plus 18 equal to 0. Okay? Now, we can actually divide both sides by 12. So, what's left is ito na lang, x squared minus 11x plus 18 um, equal to 0. Right? And x squared minus 11x plus 18 is factorable. So, the factors are, we have x minus 9 and x minus 2. So from that, we can now solve for the values of x. So we have two values of x here. We have x minus 9 equal to 0. So x is equal to 9. And we also have x minus 2 equal to 0. So x is equal to 2. So we have two values of x. However, we will only take those values that are within or that is within the closed interval 0 to 4.5. So therefore, since 9 is beyond 4.5, we will not take x equal to 9. So we will only take x equal to 2. Okay? Hence, x equal to 2 is a critical point. Okay? So after that, we will now compare the values of f at the critical point and at the endpoint. So we have x here and we have v of x. So let us now um compare. We have the endpoint 0, the first critical point, which is 2, and the other endpoint 4.5. So let us now try to substitute the value of x to our original function, v of x. So we will have, you substitute 0 here, so you will have 0, right? Next, you substitute 2. So that will be 25 and 2. So 200. So this is 200. And for 4.5, you will also have 0. And since we need to give the largest volume, we will take 200 as our final answer. Therefore, the largest volume of the box is 200. Then include the unit of measurement. We have centimeters, so we have cubic centimeters. And this is now our final answer. Okay? Now, for our last problem, we need to determine the dimensions of the right circular cylinder of greatest volume that can be inscribed in a right circular cone of radius 6 centimeters and height 9 centimeters. So, here ang hinahanap ay dimensions ng right circular cylinder. So, the dimensions are the radius and the height. Okay, so yung hinahanap natin dito ay yung radius at yung height. First step, kailangan nating i-draw yung appropriate diagram for the problem. So ang sabi dito, yung right circular cylinder, ipapasok natin sa right circular cone. So therefore, suppose we have first a cone. So suppose this is our cone. Okay, so yan. So, lagay natin dyan. Ayan. So, the cone is 9 centimeters yung height. So, this is 9 cm. And the radius is 6 centimeters. So, from the center going to the edge, that will be 6 centimeters. Okay? And the right circular cylinder, ipapasok natin ngayon sa cone. So suppose this is our cylinder. So suppose ito ngayon yung cylinder natin. Ayan. So we now have a cone and a right circular cylinder. Okay? So we are done with our what we call this one, illustration. So let's proceed with the step 2. Use variables to label the unknown quantity. So first, yung unknown natin ay yung dimensions ng cylinder, right? And that is the radius and the height. So first, we let R and H na lang be the radius and height of the right circular cylinder respectively. And we don't know also the volume of the right cylinder, circular cylinder, and V of R. So suppose we will just only use the radius mamaya. Okay? So in that case, since ang function natin should have one variable only, so we will write the height h in terms of the radius r. Okay? V of r be the volume of the right circular cylinder. Okay, so there. Okay. Take note the formula in finding the volume of a right circular cylinder is given by V equal to pi r squared h. So we need to know our radius and our height. And we need to express our height in terms of the radius. Kasi, as what I said kanina, yung variable natin na gagamitin ay CR lang. One variable lang dapat. Okay? So in this case, since we let the radius and the height of the right circular cylinder be R and H respectively, therefore from um our illustration, this will now be equal to H, itong nandito, right? And from the center, yan, this will now be R, right? So from that, now looking at the cross section or the central cross section of the cylinder and the cone, we can actually see two similar triangles. So ano ba yung mga triangles na yon? So tingnan natin itong central cross section niya, makakakuha tayo ng dalawang similar triangles. The first one ay ito. Okay, itong green na lang. So, itong nandito, yung maliit na triangle. Ayan. So, lagay ko lang siya dito para makita natin yung comparison. So, ito yung first triangle natin. Ayan. Okay. And the second triangle is yung malaki. Ayan. Right? So, that is our second triangle. So, pag ganito siya. Right? Ayan. Okay, so we have now two similar triangles. Now, ilagay natin yung radius at height or yung base and height ngayon ng mga triangle. Now, in this case, yung malaki, alam natin na this is 6, right? And the height is 9. Okay? Now, in this case, itong nandito sa yung maliit na triangle, yung height niya is h, while itong nasa base niya, take note this is 6. Okay, and this is R, itong nandito. But we only need this length here. So therefore, we just deduct R from our 6, makukuha natin ito. So that will become 6 minus R. Okay? So from that, since we have two similar right triangles, we can do ratio and proportion. Okay? So from that, we will have 6 minus R over 6 is equal to, so this base is to this base, equal to this height here is to this height. So we have h over 9. Okay? So from that, we can now solve for h. Okay? Just multiply 9 both sides. Multiply natin itong 9 both sides. You will have h equal to, mawawala yung 9. So this is 3, this is cancelled out. This will become 3 over 2, right? So you will have, this is 3 times 6, you have 18, divide by 2, you have 9, minus 3 times r, so 3r over 2, or just 3 halves r. So this is now our h. Okay? Thus, we can now give the objective function. Okay, thus, v of x is now equal to pi times the radius square and our height, which is 9 minus 3 halves r. Okay? Para mas madali nating ma-differentiate mamaya, let us, what you call this one, distribute. So we will have, this is just 9 pi r squared minus 3 halves pi r cubed. Okay, so we are now done with our objective function. And we proceed to the close interval. We need to determine our close interval. Take note our, oh, so this should be v of r pala, sorry. So let's erase this. This should be v of r. So there. Okay. Now, take note our variable is r. So we need to check the restriction of our r. R is the radius of the cylinder. And take note our cylinder only is restricted from this one to here only, right? So that is from 0 to 6. Okay? So that we can maximize the volume of our right circular cylinder. So that is from 0 to 6. So therefore, where R now is an element of the closed interval 0 to 6. So that will be our restriction from 0 to 6. Okay? So we can now differentiate this one. It follows that v prime of r is equal to, differentiate 9 pi r squared with respect to r. So that will become 18 pi r. Okay. And we have minus, this one is 9 over 2 pi r squared. Right? Okay. Or we can factor this. So we can factor out 9 pi, right? So factor out 9 pi. So that will be 9 pi r. Pwede rin si r. So 9 pi r times, this will become 2 minus, we have r over 2 na lang. Right? If you will try to distribute this, babalik yan dito. Okay? So that's it. So we are done finding the derivative. We will now equate it to 0 para makuha natin yung critical point. So equating v prime of r equal to 0, we obtain, ayan, 9 pi r times 2 minus r over 2 equal to 0. So from that, we can actually solve for r. So we will now have, so dito na lang, equate the two factors to 0. 9 pi r equal to 0. Therefore, r is equal to 0. And we have 2 minus r over 2 equal to 0. Lipat natin yung r over 2. So we will add r over 2 both sides. Magiging 2 equal to r over 2 siya. Right? Multiplying 2 both sides, you will get r equal to 4. So we have two values of r, and in this case, 0 and 4 are elements of the closed interval 0 and 6. So we will take the two values. And since 0 is already an endpoint, so tatlong values na lang yung i-compare natin. Okay? So comparing the values now, we have r and v of r. So we will now have 0, 4, and 6, right? So when your r is 0, you will get, so you substitute it here in our original function. So you will have 0. Okay, you try to substitute lang 0 to r. Then substitute 4 to r here, or here's a second. You will get 48 pi. Okay, and 6 substitute to this one here, to r, you will get 0 also. And since ang hinahanap natin ay yung dimensions wherein we will get the greatest volume, so largest volume yung kunin natin, and that is 48 pi. Therefore, the volume of the right circular cylinder is largest or greatest when your r is equal to 4. Thus, we say the um, dimension of the right circular cylinder of greatest volume are r equal to 4 and r equal to 4, the unit of measurement is centimeters, so 4 centimeters, and h equal to, use the formula here. So you substitute h, your r equal to 4, so that will become 9 minus 3 halves times 4. And that is just 9 minus, so this is 2, minus 6 is 3. And that is 3 centimeters. And that ends our solution. So there. So from that, we have come up with the dimensions of the right circular cylinder of greatest volume. And those are the radius equal to 4 centimeters and the height 3 centimeters. Okay? So that ends our solution for problem number 3. And this also ends our discussion in solving optimization problems. I hope you have learned something. Thank you for watching.